and the contents of our presentation is what is microwave oven, the requirements of microwave oven, what is the difference between microcontroller and microprocessor, the PIXM lab, the CLCD of our PIXM lab, matrix keypad, ISR, timer, project implementation demo. The topics learned during the internships are Introduction to C, conditionals, loops and operators, arrays and pointers, functions and strings, storage classes, Introduction to embedded system and microcontrollers. We are using the tools MPLab IDE, Cross CB, PIXM Lab, Introduction to various peripherals of PIC16F877A, interfacing various peripherals of PIC16F877A. We had some multiple quizzes and we have also attended the DISA workshop. So first of all, what is microwave oven? Microwave oven is used to heat the food using microwaves, which is in form of electromagnetic waves. There are several modes in various microwave oven. We are going to implement 4 modes, and they are micro mode, grill mode, convection mode and start mode. In micro mode, this mode is used to cook the food in traditional way, and it uses the maximum power of 900 watts. In this, the maximum time that you set for cooking is about 60 minutes. And the second mode we have is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set time as per the requirements. So the requirements to build the project is MPLab IDE, Cross CD compiler, the PIXM lab, and the PIC16F877A, and the CLCD is 16x4. Then we have used tactile switch and MKP timer 2. So what's the difference between microcontroller and microprocessor? An integrated circuit which is capable of being programmed to perform a specified task. It has a design restrictions such as memory size, input or output capabilities, peripheral functions, etc. Choose a microcontroller based on applications like performance, price, availability of tools, and special capabilities. MKP. What is MKP? It is a matrix keypad. This is used when more number of user inputs are required and still want to save some controller input-output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. So, what is the difference between microcontroller and microprocessor? Microcontroller are all the components will be in a single chip, less flexible and less designed. Complexity microprocessor microcontroller 12 and 2. Microprocessor. All components are assembled separately, more flexible and more design complexity. So we have the diagram, the difference between microprocessor and microcontroller. So the PIXM lab we are using, the architecture of PIXM lab is in this kind, and it has LED, buzzer, digital keypad, SSDs, matrix keypad, CLCD, ADC, temperature sensor, and RTC, GRIO. So what is CLCD? It is character liquid crystal display. In PIXM lab there are two types of display. 16x2 display, this is our 16x2 display, and we have 16x4 display, and this is our 16x4 display which we are going to use. It displays the ASII character and some special character, two types of communication modes, 4-bit mode and 8-bit mode. So interrupt. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. Then it goes back to the processing where it was gone interrupted. Next, ISR, Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register content that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack. Timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time and generating delays, etc. between the events. Timer or counter is a software designed to count the time interval resolution, which is also called register with 8 or 16 bit, etc. Tie is referred as the change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick scaling, may be pre-scalar or post-scalar, may be 1:1 or 1:8, etc. So, this is our project. This is the screen where when we power on uh, our Pixim lab, we will be able to see this CLCD powering on microwave oven. So these are the four modes we get in our microwave oven, which is micro, grill, convection, start, and next the for the if we select the one for the grill option, then we'll have this, and then next we have if we want to stop, we can use the number 4, and if we want to pause, we can use the number 5 option. And it is the timer display. This is a project program which has been written as the project name is Micro Oven, and there are several files involved in this. As we can see, here is the header file, and in this several sub files are involved to create the project. Important files, link files, source file. In source files, we can find the main files which are required to build during the project, and this is the main C file in which we can see that uh, the program is written the program is written as per the requirement, and we have used many if else conditions, switch cases. First, if we want to check whether our program is correct or not, we have to build the program. As we are building, it takes some time. Now it is built successfully as shown, and now we have to convert our main project file into we have to build our main project file so that it converts into hex file. As we can see here, it is being converted into the hex file. Now let us move to the project, Pixim Lab. Here, first we have to load our hex file, the file which we have been converted. Now we have to open it. Let's start the oven. So here, when we power on the oven, it is displaying power on. There are four types of options, modes. The first mode, If we select 1, it performs the operation for micro. If we select 2, it performs the operation for 2 grill. If we select 3, the operation will be performed as convection, and for 4, it to start it. Now let us see. We have used 16 into 4 LCD as it is shown here. Now let me start micro first. So I am clicking 1. See here it is showing us set time. The time. We have to first set the time, and you can use these numbers. Now I am giving 6 time. Now it is displaying 6 as time. If you want to resubmit the time, we have to use hash as it indicates it is clear. Sorry, star. If we use star, it clears the time, and now we can reset the time. Now let me use 5. Now 5 time is given 5 seconds. So if I enter hash, it will enter and start rotating our cooler here. We can see that the oven is running now. Now again, if I want to use grill, then I'll use 2. Now it's asking me again the timing. So I'll take 9 to show you more time. Hash. Now you can see here, if I use 5, it is, if I click 5, it paused the cooler and it also paused the micro oven. If I use 4th option, it will start or resume my oven automatically. If I click on 6, it will stop my oven. So let's see 4, I'm clicking 4. So it is started again and resume. Now let me try 6 and it displaying the time is up. So this is how a micro oven project is being done. Now we can see the third option, that is convection. Here, same. They are asking us to set the temperature. So we'll keep this temperature 55. So let us enter hash. The time remind is given here. This is preheating. Here the oven will be preheated first before it goes to the actual performance. Now it's taking a time. It's displaying the seconds like it's preheating for. Now it has set. Now it is asking for us to set the time. We have used convection. Now third option, which asked us first to give the preheating time. Now it is asking us the actual time to how much the food need to be cooked. So let us give again 8 and press enter. So it is showing here. If I want to stop, I'll use the 6th option to stop my oven. If I want to cancel it. If I want to start, just click on 4. It automatically comes back to the previous function which it was performing, which was convection. See, we can see here the time remaining is this, and we can start or stop by 4 to start, 6 to stop, and 5 to pause. When we pause, we can see the relay 1 is off, and when we start, that is 4, we can see the relay 1 is automatically on and it is performing the operations in the port TD. We can see here, and at last it shows the message time's up and your food is cooked. This was our project used to build the microwave oven. Thank you so much.